Hey guys, during my teaching experience for GCSE students, I have observed many times that students understand everything, but it's hard for them to organize the whole knowledge which is the key to success in exam. That's why I made the 2 summary sheets of GCSE Maths first section number, which you can download through the link in the description box below. In one sheet, I have included the examples, while in the other sheet, examples are not included. And in this video, I'll explain the whole sheet in detail with examples. Good news is that this covers all the exam board and both foundation and higher tier. Higher tier students has to cover all, while foundation tier students don't need to cover the brown color text because that's only for higher tier students. So let's start the video. One thing I want to tell you here that few questions I already included in this sheet which I thought is necessary, and few I will solve in this video. So the first thing is that the priority of operation in calculation, which you have to remember, means whenever you have to solve multiple calculations at the same time, like addition, subtraction, removing brackets, indices, so you always have to follow the BIDMAS rule. So the first priority would be the brackets, removing brackets, indices, division, multiplication, addition, and then subtraction. After that, here is a prime factorization, means you have to break down the number into its prime factor. For this you have to use tree diagram. So let's suppose here we have to do prime factorization of 45. So how you can do that? Write down two multiples of 45. I am going to write here 3 times 15 and further 3 times 5. So all these 3, 3, 5 are the prime factors of 45. So here I did 2 steps. Sometimes you have to do more than 2 steps, so you have to follow on until you get all the prime factors. So you will write like this: 3 times 5, and whenever you will see you will have same numbers, like here 3 and 3 are the same, you will write them in terms of bar. And the next is least common multiple and the highest common factor. For least common multiple and the highest common factor, there are the multiple methods, but I would suggest the best method is the Venn diagram method. For this you have to do first of all prime factorization of each number, then you have to fill Venn diagram. So middle part shows shared parts, so here you will write down the common factors, and here you will write down the uncommon factors. And when you multiply all the common prime factors, you will get the highest common factor, and if you multiply all together, you will get the least common multiple. So let's suppose we have to find least common multiple and highest common factor of 45 and 12. So for 45 I already have done here prime factorization, and for 12 we can do like this: 2 times 6 and then further 2 times 3. So now if you look the common prime factors between 45 and 12, which is 3, so you will write down here. And let's suppose 45 represents first circle and 12 represents second circle. So here you will write uncommon part of 45, which is 3 and 5, and uncommon part of 12, which is 2 and 2. And whenever you will multiply all the common prime factors, so here is 3, so highest common factor would be 3 in this case, and least common multiple you will multiply all together. So 3 times 5 times 3 times 2 times 2 equals to 180. And then product rule of counting: if there are A ways of doing task 1 and B ways of doing task 2, then ways of doing both tasks is A times B, means you have to times the both ways. So let's take an example. In a restaurant there are 3 different starters and 6 different main meals to choose from. So how many possible combinations are there when choosing a starter and a main meal? So you can find the total possible combinations using product rule, means you have to times the both. So mean there are 18 total possible combinations. And then percentage calculation. In percentage calculation you will have 3 types of question. The first is straight away you have to find percentage quantity, and for that you have to divide percentage value by 100 and then multiply with the quantity. The first example is related to the first type. 35% of 300 you have to find. For that, what you have to do, divide 35 by 100 and times by 300, or you can do like this, 0.35 times 300. In both ways you will get the same answer, 105. The second type is that you have to express one quantity as a percentage of another. For that, you have to divide one quantity with the second one and times with the 100. The example of this type is that you have to find 36 as a percentage of 200. So you can express like that, 36 divided by 200 times 100, which will give you 18%. Here I want to tell you one thing, that whenever you have to convert percentage number into normal number, you always have to divide it by 100, and whenever you have to convert normal number into the percentage number, you always have to times with the 100. So in the third type is you have to find the percentage change could be increase or decrease. For that, you have to multiply the mean quantity with the multiplier. How you can find this multiplier? Let's see in this example. You have to decrease 300 pound by 12%. So if this is the decrease, means you have to take away 12 from the 100, so you will get the 88. So means you have to find 88% of 300 pound. So let's suppose if I change this question like increase 300 by 12%, then what you have to, you will add 12 into 100, so you will get 112%. So means you have to find 112% of 300 pound, or you can do like this, 1.12 times 300. Then fraction of a quantity. For that, you need to multiply the quantity with the fraction. For example, 2 by 5 or 45 pounds. What you have to do, multiply the fraction with the quantity, and you will get here 18 pound. And then calculation of fraction. Whenever you are doing calculation of fractions, you always have to focus the denominator. In case of addition and subtraction, denominator should same, while in multiplication and division, it's not necessary. In first example, we are adding two fractions. So if you look, the denominator is not the same, so we can't add. So for that, we have to make them same. So how we can do that? We multiply the first with, actually we multiply the numerator and the denominator both with 3, and here we multiply numerator and denominator both with 5. So we will get the same denominator 15, and if the top we multiply 3 times 3, we'll get 9, and 1 times 5 we will get 5. So now the denominator is the same, so straight away you will add the numerators, so you will get the 14 divided by 15. So same you will do in the case of subtraction. Now in multiplication, as I said, denominator don't need to be same. So look here, they both are not same, so it doesn't matter. So you just straight away times numerator with the numerator and denominator with the denominator. So 3 times 1 will give you 3, and 5 times 3 will give you 15. So here I'll solve another example of division as well, so you will see how you can divide the fractions. So let's suppose you have to divide 3 divided by 5 divided 9 divided by 5. So for division, what you have to do, you have to focus on the second fraction. So for that, the first step, that you have to change this sign with the multiplication, and for that you have to flip the second expression. You have to take inverse of the second expression, so you will write like this. And now you can multiply top with the top and bottom with the bottom, so you will get 15 divided by 45. This is not the final answer because you can simplify it. This is divisible by 15, so you will get 1 divided by 3. And then ordering numbers. So in this you will get the mixed type of numbers. They will give you maybe a percentage and fractions, decimals together. So whenever you are going to order them, they all should be in the same form. You could convert all them into percentage or decimal or fractions, but I would suggest better to convert all in the decimals form. So let's suppose we have 3 numbers. The one is 0.2 and the other one is 1 divided by 8. And here is 35%. You have to order them in a ascending order. So for that, the first one is already decimal, so this one you have to convert in the decimal. So you will get 0.125, and this one you will get 0.35. So look, the smallest is this one, so you will write 1 by 8 first, and then 0.2, and then 35%. This would be the answer. And in standard form, there are the two parts. The first part is the number part and second part is the index part. Number part could be always one digit number starting from 1 till 9, while index part there is a power n and could be positive or negative, but it's always an integer. And in moving decimal, you have to remember one thing, that whenever you are moving decimal, exponent will always change. If decimal point moves left, exponent goes up. If decimal points move right, exponent goes down. In few questions, you have to do the reverse, mean if exponent you will change, then decimal point will move. So if exponent goes up, decimal point moves left, and if exponent goes down, decimal points moves right. So you should remember in both ways, and you will see examples of moving decimal in calculation of standard form. In calculation of standard form, you have to focus on powers of 10. You can only add or subtract when powers of 10 are same, otherwise you can't, and multiplication and division of power of 10 does not matter. In first example, look, power of 10, here is 8, here is 7, so they are not equal, so you cannot add. So to add, you have to make them same. You can make 8 to 7 or 7 to 8. I actually convert 7 to 8. So look, to convert 7 to 8, exponent goes up by one digit. As I explained before, whenever exponent goes up, decimal always moves toward left. So look here, 7 moves to 8, one digit increase. So you have to move one digit, this decimal, to left. If here is nothing decimal, so mean here is decimal. So 3 becomes 0.3 and 10 power 7 becomes 10 power 8. So now look, they both are same. So now you can add number part with the number part, and this part remains same. So you will get 4.3 times 10 raised to the power 8. Same you will do in the case of subtraction. Multiplication, as I said, powers does not matter. So how you can solve it? You will multiply number power with the number part, and in case of index part, whenever the case of multiplication, you will add the powers. So look, 4 times 3 you will get 12, and when you add the powers you will get 10 power 13. And in case of division, what you have to do, you will divide number part with the number part, and in the case of index, what you have to do, you will subtract the part. So in multiplication you have to add the powers, while in division you have to subtract the powers. Now next is comparing standard form. So whenever you have to compare the standard forms, so first thing you have to compare the index part, and then you have to compare the number parts. So let's suppose we have the two numbers here. The one is 2 times 10 raised to the power 5, and the second number is 1.5 times 10 raised to the power 8. So look, if you look the number part, it seems like that the first is greater than the second one, but as I said, you have to focus first of all the index part. So if you look the index part, 10 raised to the power 8, this one is greater than as compared to the first one. So basically you will say the second is greater as compared to the first. So now if I write another example, 5.83 times 10 raised to the power minus 3, and here I'm going to write 6.1 times 10 raised to the power minus 3. So now look, index part is the same. So whenever index part is the same, then you will compare the number part. So now if you compare the number part, 6.1 is greater than 5.83, so second number would be the greater. So means always you have to compare first the index part, and then you will compare the number part. In conversions, you will have to convert one unit into another, and here there are the different quantities like the mass, time, length, and money. You will deal a lot of questions in which you have to convert these quantities from one unit to another, so you have to remember all these. For example, if you convert gram to kilogram, you always have to divide it by 1000, and if you convert kilogram to gram, you will multiply the quantity with the 1000. Similarly, if you convert from second to minutes, you need to divide it by 60. If you convert minute to second, you will times by 60. From minute to hour, divided by 60. From hour to minute, multiply by 60, and so on. So you have to remember all these conversions. And then surds. So first of all, you should know what surds are. Surds actually the square root which cannot be reduced to a whole number, fractions, recurring or terminating decimal. And how you can simplify surds, for that you have to look the biggest square factor of number always. For example, if you need to simplify under root 80, so you have to look the biggest square factor, which is the 16 here. So 16 times 5, you will get the 80. So as 16 is the square of the 4, so 4 comes out, so you will get 4 under root 5. In calculation of surds, you have to focus on surds. In addition and subtraction, surds needs to be same, otherwise you can't add or subtract, while in multiplication and division it's not necessary. Look in first example, the both surds are same. Under root a and under root a means you can subtract them. So how you can do that? You will subtract number part with the number part while the surd part remains the same. So 3 take away 4 will give you -1, and this part you will write down as it is. So you will get negative under root a. In the second example, look, the both surd part are the different, means it's not possible to subtract them. Third example is the example of the multiplication. So look, the both surds are different, but as I said before, it's not necessary that surds to be equal in multiplication, so you can multiply them. So how you can do that? You will multiply number part with the number part and surd part with the surd part. So 3 times 4 will give you 12, and 8 times b will give you ab, so it will give you 12 under root ab. In rationalizing, the denominator means you have to get the root out of the denominator. So whenever in the question you will see in the denominator there is a root, so means you have to get the root out of the denominator. So how you can do that? You actually need to multiply the numerator and denominator by an expression that makes the denominator an integer. So in rationalizing the denominator, you will deal two types of the question. In the first question, in the denominator there will be only one root. So how we can remove this root from the denominator? We just multiply the same thing with the numerator and the denominator, and then we solve it. So when we solve it, we will get a times under root b, a under root b, and under root b we can solve like this: b times b, and it will give us b square, which will give us b, which is here. And in the second example, the denominator is the addition of two numbers. One is the simple, one is the root. So how we can solve this one? We will take the same thing but with the opposite sign, opposite middle sign, and we will multiply with the numerator and the denominator, and then we solve it. We get a times a minus under root b, and at the bottom a plus under root b times a minus under root b. Let's suppose we have to rationalize 2 divided by 3 plus under root 3. So this is similar like that one. So what you have to do, you will times numerator and denominator with exactly this number but opposite middle sign. So you can do like that: 3 minus under root 3 divided by 3 minus under root 3. And next you have to solve it, means times top with the top and the bottom with the bottom. So you will get 2 times 3 minus under root 3 divided by, here you can multiply two expressions straight away, or you can use this formula: a plus b times a minus b equals to a square minus b square. So I am using this formula, but you can use multiply two expressions like first with the first and first with the second, and second with the first and then second with the second. So I'm using here this formula. So you will get a square mean 3 square 9, and then minus b square mean under root 3 square, and you will get 3, and then 2 3 minus under root 3 divided by 6. And now you can divide 2 by 6. So 2 times 3 is 6, so you will get 3 here, and then you will get 3 minus under root 3 divided by 3. And you can further simplify it. You can split the denominator. So you can write like this: 3 minus 3 under root 3 divided by 3, and this can be cancelled out, and you will get the final answer 1 negative under root 3 divided by 3. So this is the final answer. 1 minus under root 3 divided by 3.